in the previous lesson, we mentioned this potential issue with sending or actually saving the data into database and then publishing the event to the message broker. But given the fact that we have like two different parts of infrastructure, being database and message broker, we cannot really guarantee this transactional approach, right? Because these are like two different parts. So there is no like one big transaction that would wrap, publishing the event and saving data into database, right?
Yeah.
Because like RabbitMQ and MongoDB or SQL Server. So we will need to find a way to somehow fix this and somehow deal with this challenge.
Yeah, I think that we should mention that actually we have two issues in here. Mm-hmm. So the first one is that we described at the very end of the previous module, in which we do some changes to our microservice, and then for some reason the microservice dies with no message published to the outside. So this is more like the outcoming messages potential issue. The other one could be, since we do the whole communication between the RabbitMQ and the microservice is based on the ACK, it could happen that we would not process the message and we would not send the ACK. RabbitMQ in this case would try to send this message right after, again, and that would potentially lead us to the situation in which we would process the same message twice or even more times, right?
Right. So we are talking about this scenario where we have this line of code within our RabbitMQ subscriber. So here we are invoking our message handler, and it may happen that we, for example, invoke this handler. This will result in saving data to database, but then on that level, this ACK will never reach the RabbitMQ. Yeah. Maybe our application will somehow die. Maybe there will be some issue with networking. It will not reach the RabbitMQ. So then RabbitMQ, based on custom settings, will, for example, try to send us this message again because it didn't receive the ACK maybe within 10 seconds.
Yeah, actually, to be more precise, the RabbitMQ will not send this to us. It simply will keep this in a queue. So once we actually restart the microservice, we'll have the same behavior as we had in with the customers, right? So we actually connecting to the RabbitMQ to the particular queue as a consumer, and we're grabbing the message and try to process this again, even though we process this.
And it may even happen that it will happen a few times in a row. Yeah. So like potentially there might be like 2 retries or 10 retries, right? So we need to do like 2 things. At first, ensure this atomic or actually unique processing of a single message only once, even if we receive the same message multiple times. And on the other hand, we need to ensure that we'll never lose an event, that this save to database and publish event to this message broker will never, will always succeed.
Yeah.
Right? All right. So let's see at this slide that we need to start thinking about this message delivery mode, right? How it might work in general. Because what we would like to have is we like to have this exactly once delivery mode, meaning that there is like no networking, between the message broker and our service. And once the RabbitMQ, sends us this message, pushes this event to our application, it will never happen that what you described, like this scenario where we might kill the app and there will be already a handled message and we receive the same message again and again, and we'll, for example, send the payment or transfer money multiple times, right? So we like to somehow deal with this potential issue.
Yeah, the delivery mode itself, we can distinguish 3 different types of this this delivering. The easiest way would be delivering at most once, right? So this is more like you mentioned this fire and forget, right? While we actually publish some message, and this might be eventually processed, but if it's not, then we don't care. We don't keep the track of this message. So the only thing that we do is simply publish this once, and we don't care whether this will be processed or not.
Yeah, so we'll receive, for example, like at the slide, this order created event, but if something goes wrong here, the message broker will not care. It sends us the message only once, and it doesn't care whether we failed with processing it or not.
So we have this automatic ACK in which we simply say, okay, whatever.
Yeah, but for like most of the scenarios, I would say, when we don't want to lose messages at any point and we really care about processing them, it's probably not what we want. So then we would usually switch to this at least once delivery.
Yeah, this is more way better approach because the whole idea is based once again on the ACK, in which if we don't provide this, then we'll probably try to process this once again, right? So in the happy path, we will simply process this once. If not, then we'll try to process the same message over and over again. And here, this is the mode in which the idempotency shines actually, and this is why we mentioned this, that the possibility of having the message idempotent is pretty cool when it comes to and crucial when it comes to distributed system, because if we think about the at least once delivery, having the idempotent message and the idempotent processing of this particular message makes it pretty easy with the at least once delivery. Because if we will, even though we'll process the same message over and over again, let's say 10 times, the result will still remain the same, right?
Yeah, I mean, sometimes it's possible, like update, change my name or change my address, right? I can't be named like Peter more than once. If I'm Peter, then I'll always be Peter, even if someone sends 10 updates. If I delete the account, I cannot delete the account more. It's already deleted, but it's not always.
Some operations are idempotent by the nature, right?
If we could do it for the whole handlers, it would be great. Then we probably wouldn't care about this issue, but it's not always the case. Let's say transfer the money or anything else that cannot be easily verified. It cannot be idempotent by the nature. Sometimes it's not that easy. So
and the very common example is calling some external system. So we have no control out there. We would like to call them just once. This is the case in which we cannot do this idempotently.
Right. So we'll need to somehow provide this exactly once processing. And as you might remember, we talked that our message contains like multiple properties, like timestamps and some IDs. And the most important part here will be this message ID.
Yeah, so the unique identifier.
Yeah. And so we want to have a unique identifier for each message. And the important thing is that we, as developers, we can actually set this identifier on our own, which will be also needed later on once we talk about these patterns in practice. So let's go to the next slide. So we want to have this exactly once processing. And the way it might work, or actually the way that we might achieve this result, is by actually relying on the good old-fashioned database transactions, right?
Okay.
Even if it's SQL transaction, or even in MongoDB, you can have transactions as well, since one of the latest versions on the replica sets.
Yeah.
So we'll need to rely on the database transactions to overcome this issue. And the way it might work is the following. So at first, when we receive the message from the broker, let's say we receive this order created event or create order command, whatever that message is, we will need to store somewhere, maybe in some dedicated table within our database. For example, list of the all messages or just messages IDs. Like the message ID will be the most important factor here that we already processed, right? So at first we will check, okay, did I process this message with this ID? If it's in this, let's say, processed messages table in my database, then I just send back the ACK to RabbitMQ, because for any reason I just received the same message again. So I'm just telling the message broker, hey, I got this message processed already, give me the new one, right? But if it's the first time I'm receiving this message, then we will invoke our handler as we usually do. But once we, for example, save our data into database, so for example, if we move back here, when we call this update async, we will also need to save this uniquely processed message ID into this separate table. So for example, somewhere here, I would do something like save processed unique message ID, all right?
Okay, so to make it clear, we will have a shared database transaction. So we will, so basically this transaction means that we will either save both the, whatever we change inside the handler, together with the message ID, which will be put in the separated collection. So we have this guaranteed that we'll save these two things at once in one transaction, right?
Right, and this is why it's crucial that we must have transaction and we have to use the same database, because otherwise, if we decide to keep this process messages maybe in Redis and data in SQL Server, then we cannot have the transaction again. So we will need to have like a separate table that will keep at least the process message ID, and we save it as a single transaction, like a transaction where I save process message ID and maybe some other data if I need it, and the actual aggregate that is part of this transaction.
So the result would be, we have two possible scenarios. So first one is that we will successfully save the data to the in the MongoDB, and we will also have this information that we've processed the message with the particular ID. So assuming that with the ACK would be not provided with the RabbitMQ and would start processing the same message again, we would firstly check that this was already processed, and we would send this ACK for the RabbitMQ.
Yes.
And the other one would be that something happened, we did not commit both our message ID and the data inside let's say the resource, right?
Exactly. And this exactly once processing, we would pretty much call this process messages table, and this pattern in general, the inbox pattern, right? So we have an inbox and we just verify whether this message has been processed or not, and we want to ensure this unique processing based on this, based on the database transactions. This is how we can actually deal with it, by using good old-fashioned transactions. All right, so we discussed this inbox pattern, right, and how we can guarantee this exactly once processing, at least in theory. We'll get to the code soon. Now let's talk about this outbox pattern, right? How we can guarantee that we will never lose the messages, and we'll have this guaranteed delivery mode, right? Because usually these two patterns are related to each other. I mean, we could use them separately, but usually it doesn't make sense to have only the inbox without this guaranteed delivery, or only this guaranteed delivery without the inbox, because we could receive the same messages multiple times.
I would say that if you would have to pick, I would go for the outbox only, because the inbox, this processing message just once, can be, let's say, overcome by having these idempotent messages. But this one actually cannot be done other than, I think, the other way than the following. So the idea is that actually it's based on the same concept. So we'll once again use the database transaction to make sure that our message will be persisted together with the data, business data. So basically, once we start processing our message inside the handler, let's say the order created, or maybe the create an order, right? Yeah. So we will insert some order into our MongoDB collection. So we'll simply do some insertion, but in the same transaction, we will also, let's call this an outbox collection. We will put the payload of our message that we eventually want to send to our microservices. So basically we'll have two insertions in one transaction. One is just the order, and the other would be the message integration event actually that we want to publish. Now, this will end up the whole handler processing, and there is one piece missing, and this is called the Outbox processor. Basically, this could be like a background job or whatever. So basically, the responsibility of Outbox processor would be, so for some determined interval, simply looking into this Outbox collection and checking whether we have anything to send, right? So basically, we will mark whether the message was published or not. So basically, we will see, okay, so let's say that we every 3 seconds will check whether we have something new in Outbox. Okay, so we have new message. This is called order created. We'll simply take this from the database and use the message broker to actually publish the message to the microservices. And now we have a question here, because in theory, this could happen that we would take the message from the Outbox, publish this, and then our microservices would die, and we would have, the processor itself would have no chance to actually update the information that the message was actually taken from the Outbox. So eventually, once the whole microservice would be restarted, we would send, the processor would take the same message from the Outbox and publish this again. Yeah. But once again, if we would have the inbox and exactly once processing, this is not an issue for us.
Yeah, so it doesn't matter. We need to only remember that whenever we are republishing the same message, we just have to guarantee that the message ID will be always the same.
Yeah.
Because once we start publishing the same message, but we'll change its ID, then the inbox will just check, okay, so this is a different ID. This is a new message, right? So eventually, if you want to make these two, inbox and outbox, work together, so we would have a single transaction somewhere on our command or even just message handler level that would do three insertions, or actually they would touch the three different collections.
Yeah.
One would be the collection of our entities, for example, our resources, our aggregate that we modified, for example, during the adding resource or reserving the resource or creating a payment. There will be one collection. Another one would be collection where we store these uniquely processed message IDs. And the last one, given that we have any integration events to be published, would be this Outbox collection where we store the events to be published. So it's either all in or nothing.
Yeah.
Like either we save into these three collections with the single transaction, or we don't save anything because something is broken, right?
Yeah. So this might seem kind of complicated at first glance, but the idea basically is very simple, right?
Yeah.
So
let's get into the code. Let's see how it works in action. Okay. So we have our resource handler, and we want this to, of course, change our resource state and save successfully into MongoDB. But within our process async, we will not be publishing directly into this message broker. We want to save this event into the Outbox collection, this payload and some metadata of these events that we want to send later on. And of course, we want to have this verification of our unique message IDs, right? So somewhere before we even invoke this handler, we would like to, verify whether we can invoke this handler at all, whether this message is unique or not.
Yeah.
So it seems that we'll need some sort of like a middleware that will be invoked before we actually hit the handler. So ideally, something like if we were to look into this RabbitMQ subscriber, we would like to have, before we do this invocation here, we would like to verify before we call this handle whether we can actually call this method, right?
Yeah.
But given that we, for example, cannot change the internals of some library, we could, for example, maybe put a decorator on top of it.
Yeah, that looks like a good idea. And the advantage of having the decorator will be that we will not integrate in the code of the handlers itself. So yeah. So just to make it clear, the decorator pattern, very simple. And the idea is that the decorator will implement the same interface that the component that it decorates. So in this case, we will have a decorator that will implement iCommand handler of T. And the decorator will have the actual handler injected inside. So we'll have this sort of the middleware, but more like in shape, more like the onion. So we have the handler inside, and we simply wrap additional layer on top of this, so we can change its behavior and eventually call the handler.
Yeah. So it works like a middleware, but it's structured more like this onion.
Yeah.
So let's create a new decorator directory, and again, this will be the responsibility of another layer in application. In our case, for example, the infrastructure layer, to guarantee this processing, right? Our application layer, it will not care that it doesn't send the messages directly to the broker, as long as it eventually gets to the broker, right? So let's add a new decorator, and let's call it common or Outbox. Inbox/Outbox, just call it Outbox.
Yeah.
Common handler decorator. Let's make it an internal sealed class. And of course, it will implement the iCommand handler of T, like this, where T is a class and is iCommand interface. So here we'll put our logic for this inbox and outbox, and here we can just inject what we are decorating. So we are decorating command handler of T, so this will be it. And then we can inject our message outbox abstraction. So we have a sample implementation of this message outbox. We'll talk about it. It's internal soon. So I just inject it this way. And Now we can also maybe check if Outbox is enabled or not, because maybe for local development or for testing we will need it. So we can see that we have this enable flag within our Outbox. There is this enable, and let's just assign it to this private field. All right. Now there will be actually a good thing to somehow get our unique message ID, right?
Yeah.
Just to get it somehow from our message that we just received. So just like we do have the iHTTP context accessor for accessing the HTTP context, like in any part of code within our application, we also have the following, which is called iMessage iMessage properties accessor. So maybe let's quickly take a look at this one.
Yeah.
Where it's implemented. So we have this interface, and this interface gives us the following default properties of a message, like the message ID. About this one we'll talk later on, some timestamp, list of headers. So we can put here some common message properties, and these properties will get assigned
somewhere in the subscription.
Yeah, somewhere in the subscription. So when we actually receive the message, we will build these message properties based on the current message properties that is, for example, just received from the message broker, and we'll just pass it along, and we can inject it as our correlation or message properties accessor.
Yeah.
And this is async local, so it works similarly like the HTTP context accessor. Like the idea is pretty much the same.
Yeah.
So we can inject this accessor here, and from this accessor we can actually get our message ID. Actually, we don't need to assign it to a private field. So message properties will be the properties accessor and our properties, and the message ID that we want to process will be the following. So we can check if actually we have any message ID, because maybe someone didn't assign ID. Maybe message properties be null because it is a message that we receive from the web API, not from the RabbitMQ.
Okay.
So if this message properties message ID is null or empty, then, for example, we can assume that this is a message coming from the web API, right? So we can, for example, create some random ID or just handle it without this checking. So we could have something like, should I process this message with the Outbox? If it's from a web API call, maybe I don't need to probably do it. But if it's from this RabbitMQ asynchronous call, I will probably need to do it. So if it's string or null or white space, we can just maybe create a new one, or just have like Boolean flag, like we just said, right? Just skip it and process it as an HTTP call. Otherwise, we will get our message properties and the message ID. Okay. And eventually, when we want to process our message, so we want to invoke the handler that we are decorating, we can just do the following. So given that this is enabled, that we have enabled this inbox and outbox patterns, we can just call outbox, and then we want to handle our message. So it will expect us to pass this unique message ID that will verify behind the scenes whether it's unique or not. And then our handler, so any callback, what do we want to do with this message? So we'll just call our handler and then handle async for this message comment in that case. Otherwise, if it's disabled, we will just handle the message as usual, like this. So, okay.
Okay, so this looks pretty straightforward, but I have a question now.
Mm-hmm.
So we do have like this decorator that adds this behavior of checking and eventually calling the outbox first. But how do we actually register this? How this decorator would be actually called? And does this mean that we will have to be aware that the command handler was decorated?
No, we can simply, given that we are using Splatter, right? This library that extends built-in ASP.NET Core container with the scanning assembly features. Here we also have the decorator. We can also decorate things.
Yeah. So this decoration will take place on the dependency injection level, right?
Right,
so
right.
we'll still we can still inject our I command handler of T, but the actual implementation won't be the command handler directly, but we'll rather inject the decorator, which will
contain our original handler. We'll see it later in debug mode.
Okay.
What are the actual types? So let's just call try decorate, and we will decorate our
the open generic, right?
Open generic, right? We'll decorate our I command handler with the Outbox command handler decorator, like this, okay? And actually, we should do probably the same for the event handlers.
Yeah.
So we can do it right now. Let's just do copy and paste, and let's have the I event handler here, where T is I event, and this will be event handler decorator.
Yeah, we could put this in one class also.
Or we could have some iMessage, like generic type, base type for these sort of things. This one, and the event here. So the same for the events, right? Yeah. And let's just put the decorator for our events as well. Okay, I event handler. All right, now, before we run anything, we'll also need to actually add this outbox, right, into our code. So we will have this add message outbox somewhere. Okay, let's put it there. Add message outbox. Soon we'll see the internals, and we also like this message outbox because it's like a generic pattern, like some general approach to work with MongoDB or with SQL Server. So we can do options and then add Mongo, or add Mongo for testing, or we also have here add for SQL Server, for example, using Entity Framework, because the overall logic is pretty much the same. Okay, so we will configure this add message outbox here, and that's pretty much it when it comes to plugging it in. That's one thing. Another thing is that we'll actually now, given that we have this outbox, we'll need to change the behavior of our message broker, right? Because as far as I remember, we had this iMessage broker abstraction, and internally, it just published directly messages to our message broker by doing it like this, right? So somewhere here, we would like to verify, for example, again, if the message outbox is enabled or not, and if it's enabled, instead of sending these messages directly to the message broker,
we would like to put this.
Yeah, we like to store them in our database, right? To have this outbox pattern, and this outbox processor delivering messages for us.
Yeah. So let's do this.
Yeah. All right. So let's scroll up, and here let's inject our iMessage outbox. So the same interface that we used within our decorators, and here we can check if outbox is enabled. Then of course we will have the continue here, because we don't want to save to the outbox and then send to message broker. And here we'll actually send the message to the outbox, which will result in actually saving it into this database. Right? So we can call outbox and then send this message, this send async. We can pass our payload, being the event in that case. We will also need to pass our message ID, which is crucial, right? The message ID as an optional argument. And we can also pass here like additional data. We could grab, for example, headers from our from the event. We could grab some context. We could grab our parent ID, and so on, right? So, but that's pretty much the most important part, to have this message ID being stored along with our message.
So instead of we'll simply store this into our database. Okay. So to sum this up, this part is responsible just for the outbox, pretty much, right? So this will guarantee that the message will eventually even will have a failure, assuming that the transaction succeeded. The processor will, once we actually start working as a microservice, will simply look for the outbox collection, seek for the messages that were not sent, and will simply publish them.
Right.
Yeah. So this is the part, and where's the part that is responsible for checking the message ID?
Yeah, so this is what we have actually in our Outbox command or event handler. So here, when we are calling this Outbox handle async and we are passing the message ID,
Okay.
like behind the scenes, we are verifying its uniqueness. So maybe let's jump into this internal code and let's see what this message Outbox actually does, right? So if we open this interface here, iMessage Outbox, and for example, go into this handle async, we can see that we have the implementation with NT framework, Mongo, in memory, and we can also add any other implementation for different databases. So for example, for the MongoDB, at first, given that of course it's enabled, it will check if there is existing message ID. So if within our inbox collection we have this message ID already saved, it means that, okay, this message has been already processed and we will not call our handler, right? So our handler will not be invoked, right? Meaning that we will not invoke our command or event handler again, right? We have this unique check. If you were to use NT framework, this is pretty much the same stuff, like the same philosophy. Check. Let's get this set from our DB context, and let's verify that there is no message with this ID. If there is any message with this ID already processed, we'll just not call the message handler.
Okay.
And then so this is it. This is like the inbox part. And then the important thing is that here we are starting the transaction. And again, whether it's in the framework, like in that case, or whether it's this Mongo stuff, we want to create a transaction here, right? We're starting the transaction, and then we are calling our handler. So for example, we are calling the add resource handler, right?
Yeah.
Then we are saving into this inbox collection our new message. So here is the important part, the message ID, for example, timestamp, but this is the only part that you should actually care for, the message ID. And then we are trying to commit the transaction, right?
Okay.
And if you were to wonder, like, okay, so where's the Outbox part? Like, keep in mind that the Outbox part will be called within this handler, right?
Yeah.
Because our handler actually
we'll call
here,
the broker, and the broker will check and use this.
Yeah, because in that place we invoke this handler. The handler, for example, is this part. So here is our update that goes to this resources collection to update our aggregate. Here is the process async that we call from our process event processor. But what we will eventually do, it will call this message broker that will save these messages to the Outbox, right? So it will send these messages to the Outbox. So this Outbox part will be invoked here, and eventually we commit this transaction. So we basically touch 3 different collections. And if we were to look at this Outbox definition one more time, what the send async does, it just pretty much saving our payload into database, right? So we have this Outbox message type, we gather this ID, and we basically get some additional properties if you have like headers or anything like that, and we store our message payload. So we have our message, and we just, for example, keep it as a JSON payload.
Yeah, so this
will be event.
Yeah, so this basically is the part responsible for the storing the payload, this whole message into the MongoDB. So the question is how this message is then taken out and eventually published to the RabbitMQ.
So for this one, we have this Outbox processor. So we have this, as you can see, this is hosted service. So this runs like a sort of background job. Okay. This comes from ASP.NET Core Framework, this type. And well, the logic is quite straightforward. So basically here, we'll have the interval, and given some numeric value, which can define in app settings, we will just try to process these messages, right? So for example, here we have the timer, which is all about sending these Outbox messages. And for example, every 100 milliseconds or every 2 seconds, we will look for the messages that should be sent. So basically, we are asking our Outbox, give us the messages that weren't sent yet, that we haven't sent yet. So this one, whether we use any framework, MongoDB, will basically go to our Outbox collection, will fetch all of the messages that have this processed at null, null value. So for example, it's a datetime saying whether we actually sent our message or not. it will return all of these unprocessed or unsent messages, and our Outbox processor here will just use this underlying bus publisher to send the messages, right? So this is the place in which our message will be actually sent to the RabbitMQ or any other
and
provider.
right after we actually publish the message, we need to update the Outbox so the message will be marked as the process.
Yeah,
right?
so we can update them one by one or in parallel. So for example, here we are just calling process async, and again, depending on the underlying database, for example, with MongoDB, we are just saying update message with this ID and send this process date to the current date, right? And we just mark this message as a process one. But the important part here is that when we publish those messages, for example, using this Outbox, as you can see, we need to have the same message ID, right? So when we are saying publish async and we pass this message ID, as developers, we have to ensure that we create this message ID once, and we send it to this Outbox, and then the Outbox will always use the same message ID for the same message type.
Yeah, because otherwise that makes no sense. From the RabbitMQ perspective, this is completely different message, right? Even though the payload is the same.
Yeah. Right. So maybe let's see it in action.
Let's give it a try.
So within the app settings, you can see that we have this Outbox section, and we have this optional feature switch, like for most of the settings, whether it's enabled or not. We have the interval, so maybe let's put it into 10 seconds, all right? So we'll see the messages actually will be sent only after a few seconds, and the names of our collections, which will be inbox and outbox in that case. Also, if we, for example, have, like, say, millions of messages being sent every day, and maybe we don't want to store all of them, we could set some expiry. So maybe we want to automatically remove the messages from our collection, whether it's Redis, MongoDB, SQL Server. So we could put some index with time to live property, and then remove the messages that's been processed day ago. So we don't pollute our collection with millions of or billions of messages every day.
Okay, so
just the local setting switch, because in the local settings we have
overrides.
We have the override, so we need to enable it on the local JSON level, which is exactly here. And I think that we should be able now to start it, and we should see how it works, how it behaves. So let's give it a try. Okay, let's run this in debug mode.
Okay, so now if we will try to publish the message, let's say on the availability, once we actually want to let's say reserve the resource or create a new resource, the message, the integration event that comes right after we process the handler should not be published immediately, right?
Yes.
So we should see some delay between the actual command processing and the message that was delivered to the RabbitMQ exchange.
Exactly, and as you can already see in the logs, here we have this message, Outbox is enabled, and we'll be processing these messages, for example, every 10 seconds, and then we should see the logs that it actually tries to find some messages.
Okay.
And if it doesn't find anything, that it just won't send, will not send anything. All right, so let's try to produce some event. So for example, we can do maybe another one for adding the resource.
Yeah, so let's send this one.
Okay, let me just jump back here. So here's our breakpoint. We are creating the new message ID. We are calling our Outbox.
Okay, so that was the part in which we hit the decorator first, right?
Right. So maybe let's do it one more time so we can see it clearly. Let me just send these messages. Okay, and let's do it one more time, actually. So let's open the code. Post. And here, let's take a look. Here's our decorator.
Okay.
And here we have the actual handler type, which is the add resource handler, right? So this is what do we decorate here.
Yeah, so the dispatcher for the command, once we actually was seeking for the particular command handler, it eventually resolved the decorator, even though we have this iCommand handler type that we were looking for. And this actually, this adds this capability of Outbox.
Yeah, so this is our decorator, like you said, and here's our internal handler being add resource handler. And then we eventually invoke this one. We just call process async. and then we send our messages to the Outbox, and we can check our database that now we will have this inbox and Outbox, right?
Okay.
So within inbox, because we received this message from the web API, so we didn't even fetch this message ID from these message properties. But if you were to actually use the RabbitMQ to receive this message, we would see that there is a message ID that was set, for example, in a different service or in API gateway level.
From the HTTP perspective, we always have this processing.
So we could, for web API, we could just skip this. But for the async processing, it's actually important. And here is our inbox, right? So the ID of the message. And then we have our Outbox. So here you can see that our Outbox processed this message at this time, right? So it took him, like we said here, 9 seconds. So we had this 10 seconds interval. And maybe let's open the RabbitMQ. So we'll see that this message will not be sent like immediately, right?
Yeah.
Of course, given that we will not fall into the last second of this window, but somewhere between those 10 seconds. Right, so I will just remove these breakpoints here. And let's just do it once again. So let me prepare for this one and for database. So let's send it. Okay, let's open the Outbox. As you can see, process that is null.
Okay.
On the RabbitMQ level, we still shouldn't see the message peak. All right, so the message isn't delivered yet. Now it's been delivered.
Okay.
And if we open our MongoDB one more time, we will see that the message has been processed. So it was within 6 seconds range about. All right. So right now, even if our service, even if we kill our service, right? So we can give it a try maybe.
Yeah.
Okay. So let's do it one more time. Let's make it 10. Let's do the post. And then let's try to kill our app.
Yeah, so now we were in the state in which we committed the transaction. We have the changes in the database, but the message should not be published yet, right?
Yeah, right. So on the RabbitMQ level, let's see if we were lucky enough to. Yeah, unfortunately, we weren't lucky. Yeah, so let's run it from the console. Or we can increase the interval. We'll see.
Let's give it a shot, yeah.
All right, so we have the Outbox enabled. And let's do it one more time. 11. Let's wait. Okay. Let's see. All right, not processed yet, right?
Okay.
So on the RabbitMQ level, there is like no peak, right? So we don't have any message. The service is down, but because we have this message saved within our Outbox collection, and we can now restart the service. And let's give it a second, and it will look for these messages that haven't been sent.
Yeah, because
and it will send them.
Because we have this iHosted service, so hosted service starts right with the microservice, and will start working, right?
Right. So right now we should see the peak. So we should see that there will be a message delivered soon to our RabbitMQ.
Yeah. Okay. So this actually makes more sense in this scenario, and it gives us this resiliency. I would say on the RabbitMQ level.
Yeah, exactly. So the process that this is one. It's been processed. You can see 25 seconds after we started and then kill the service.
Maybe there's also some cold start for the hosted service as well. Yeah.
Yeah, but eventually it's been processed, right? So it's been sent to our message broker. So that's how we can actually guarantee the delivery of our messages. I mean, we will rely on the good old-fashioned database transactions, but this is how we can do it.
Yeah. So I think that we should do some short summary for the RabbitMQ and how we actually, what we've learned so far about RabbitMQ and this whole idea about the integration using the message broker, right? Because there was a lot of topics in here. So I think that some summary would be cool.
Yeah. So the most important part, like the message exchange, like the delivering of the messages, is again infrastructure. So just like we have database, we will have another piece that needs to be taken care of, right? If the message broker or service bus is down, and we rely a lot on these messages being sent and on this event-driven architecture in general, well, we things will go wrong, right? So we have to take care of it. That period.
If the broker is down, then pretty much the whole system based on the events is down. So yeah, we cannot actually make it more resilient than just trying to put this in a high availability mode. So
yeah, but the beauty of this approach is that by using the message broker, we have this isolation. So we have this decoupling between services. So just a pops up pattern where we have a publisher which is not aware if there are any at all subscribers. It just sends the message somewhere to some black box, and this black box, being message broker, decides whether this or that subscriber should receive it or not.
Yeah, and this approach also fits very well with the idea of scaling out our microservices, because keep in mind that once we actually scale up our microservice, the instances of this microservice will actually compete for the message. So eventually, even though we'll have like 5 instances of the same microservice, we'll process the message only once.
Yeah, and the good thing is also that, of course, depending on the message broker, on the queue, on the action settings, these messages will be waiting for us. So we have durable queues. They will wait for us. They will not get lost, which is usually a very important thing.
Yeah.
And eventually they will be delivered. And just like with database, our microservices will share the same queue.
Yes.
Okay. And when it comes to message serialization, on the wire it's binary, but it's up to us if we want to do this with JSON or CSV or YAML or any other format on the application level. Also keep in mind that once you start sending like millions of messages to your message broker, it might slow it down for, like you said, for RabbitMQ. It's probably better to send messages with bigger payload than like too many messages.
Yeah, but it depends on the message broker.
Depends on broker, yeah. So we have different network topologies, but we mostly, on a daily basis, I think, stick to the topic or direct. These are the two most popular ones.
But basically, the topology is up to you, and you can create. Just keep in mind that what you've seen so far inside the Paco, this is just our approach of dealing with the RabbitMQ within the microservices world. You can create one shared the exchange for the whole system, or do this completely different. The idea, the crucial thing is to simply understand the concept of the exchanges, the queues, how they are connected, how the message is transported from the one side, so from the publisher to the consumer of the message. And you can pretty much create your own topology for your particular system.
Yeah. And also, just like we said, that you need to beware of how many messages you send or how big they are. When you want to run your cluster, your RabbitMQ instance with this message persistency enabled, which is a great thing, because again, you will have this message persistent on your drive, in your database, wherever you choose to store them. It also comes with a cost, right? Additional IO operations, so a little bit downgrade in the performance, but again, you gain this persistency features. And just like we've said in this episode, like a lot of tricky parts when it comes to message processing. So we will probably stick to at least once delivery in all cases, but then we need to handle these possible edge cases where we might get the same message more than once, right? And we need to have this atomic transactional processing of messages based on their unique IDs by following this inbox and outbox patterns for guaranteed delivery, and ensuring that we will always send the events that we want to send. Yeah. So nothing will be lost and nothing will be processed twice.
Yeah, so I think that's it when it comes to the message broker. We'll move forward, because for now we do have microservices and some sort of integration between them. But the question that comes is that how we can actually play with our microservices from the outside of the world, right? So how the end user will actually interact with our microservices, because for now it looks like this is pretty complicated because we need to keep tracking of all the microservices. I'm not quite sure how we can actually interact with the multiple instances. So this is the issue that we might have.
So we've been right now using the internal web APIs, but from the end user's perspective, we will probably not see the internal APIs. We would rather see, let's say, a single gateway that we can talk to, and this gateway will be aware to which service send this message, right? So let's move forward, and also let's see how this synchronous or asynchronous message processing may have different results and may require different approaches when it actually comes to sending these requests by the users, processing them, and returning the responses to this end user, depending on whether we choose to stick to this asynchronous or synchronous processing.